Welcome to part 2 of the Ward's Airline radio restoration. I recapped the entire radio with the exception of mica caps. I eliminated the electrolytic in the back. I broke the pins off here and put in 247 at 450 volts because that's all I had. I since ordered 250 volts off of eBay for my inventory. This here is a 40 microfarad 450. That's all I had. I didn't have anything lower. So the funny thing is with these capacitors is this electrolytic here is an Aerovox. It's 500 volts. The other capacitor, the dry electrolytic, is a 40 microfarad 450 volts 525 surge. And I'm off camera again as always. Now that was right here. Now the schematic calls for 40 and 220s. Let me see, I don't even remember what I put in there. 33s, I'm sorry. 33s, I didn't have any 20s. Okay. So I ran the voltage up on this after I capped it. And I'm getting 140 something on here. I don't know, 130 here, 125, and only 109 here. So these are way over, more voltage rated than you really need. Now, my workmanship isn't very neat. I'll be the first to tell you that because I can't see what the hell I'm doing. So everything is hook and pinch, and my eyes are so bad that I can't even see to pinch them. So it's hook and solder. But I got them all in. All the capacitors have been replaced. The only thing I have to do now is to test all these resistors. I figured I'll do all the capping first and then test the resistors. I also put some spaghetti tubing over two of these wires which were bare and the insulation was coming off of them for the antenna circuit. This is the ground. Goes to the chassis. That's for when you're running an external ground. So anyways, what I did is I just simply cut the wire here, I wasn't able to pull it out, so I just snipped it and slid a piece of spaghetti tubing over it and tacked it back on here. So all my connections, as you can see, are pretty sloppy, and I'll be the first to tell you that. Now I was watching somebody's radio restoration. I can't remember who it was, but it was a video, somebody I'm subscribed to. And I remember him commenting, "I don't like seeing this," he says. Solder dropping all over. Well, it's a good thing he don't see this radio because I got solder dropping all over. Because when I'm trying to make the connection, it's falling off and dropping down. So sometimes it goes and hits something and shorts it out. So I checked everything and make sure it's not. So I hated to do that, but sometimes, I show my screw-ups and I show my good stuff too. When you got piss-poor eyesight, you have no choice. You do the best you can, and I'm trying. Not complaining, just making a statement. Okay, now the next thing I got to do now, like I say, is to test the resistors. Now I want to focus your attention on this arrangement here. This is a 1500 ohm resistor. This is a 1500 ohm resistor. This was in here. I just had to add a piece to it. I tested it. It's on value. I had to add a piece of wire to it so it'll get over to my terminal strip, which I had to add under that nut and bolt up in the corner there. This terminal strip was already here. So whoever serviced that, put this electrolytic in, put a 1500 ohm resistor here. In here, it was a 4700 ohm resistor. Both of these are incorrect. Let me show you what the schematic shows. I hope this is in focus. Looking at the 35Z4, looking at R14 and R15, the two resistors that are between the filter capacitors, okay? According to the parts list, they're supposed to be 1200 ohms. I don't know if you can even see that. I'm using the Kodak Play Touch, but I'm under a magnifying glass too, so I can't. Well, my eyes looks like it's out of focus, but it couldn't be very well. It could very well be out of focus. So I marked here 20 microfarad, and okay, 47 microfarad. Okay, so I put a 47 here instead of a 40, because that's the standard value. I think these are 33s. I didn't have any 20s. I had 10s, but I didn't have any 20s, or 22, which would be the standard value, so I used 33. But both of these resistors, according to the schematic, is supposed to be 1200 ohms, not 1500 like they are in here. But originally, this resistor, which comes off right after the input filter, this filter capacitor, 47 microfarad, comes off the cathode of the 25 or 35 Z4. Anyways, it comes off the cathode and it goes to the other 20 microfarad section, which in this case is 33. Schematic calls for 1200. Whoever serviced this put a 1500 in. And this one that went from the other side to the other capacitor between these two originally was 4700 ohms. The schematic calls for 1200 on both of these. So I split the difference and put in 1500 to match this. Okay? Now I'm not going through the magnifier now, but hopefully you can see that without being out of focus. Alright, it calls for 40 on this input, right off the cathode of the rectifier tube. Then it calls for a 1200 ohm resistor here and a 1200 ohm resistor here. And then the filter capacitor, the output filter is bypassed with a 0.1. So all that was replaced. And the only reason I'm doing this is maybe you can see this a little better. R14 and R15 are both 1200 ohms. But I put 1500 in there. So anyways, that takes care of that. So we're going by the schematic, not by whoever worked on this before. I blew up the parts list. I did a print screen and then blew it up. R14 and 15, you can plainly see it's 1200 ohm half-watt resistors. Now, judging from some of these resistors, and these are dog bone resistors, as I showed you, there's some high resistances in here. 50 megohms, so it would be 47 in the modern age. 15 megohms. 3 megohms, I may or may not have that. That's assuming that they're bad. 100 megohms. 25 ohms. Okay, here's an example. So there's a lot of very high value resistors in here. Now, some of these resistors, they don't have the dot. This green one up here does. As a matter of fact, I'll leave the light off of that because I think the flashlight's drowning it out. I can't see a dot on this brown one here. I see an end, so it's body, end, and dot, unless the dot's on the other side. So I'm going to have to go by the schematic on that. I haven't measured any of these yet. I wanted to get it recapped. In here, there's a ring that's grounded to the chassis, and I use that to ground my line bypass, which in this case is a 0.02. So I use a safety cap here. And this here, I believe, is a 0.47. This was in there. This is a 0.5, 100 volt. You can see where that band, that capacitor was in like that. Okay? So I put a 0.47 because you can't get a 0.5. And so I use this as a ground. And I also used the ground here because the original ground for the line bypass capacitor went up to one of the 2 pins, which also grounds. And then that would mean I'd have to add an extension lead on this, because the leads on these little capacitors are very short, and as you can see, I had to add a little bit of lead to it. I also put the cord on, and this is a safe set, so we don't need a polarized cord on it. So I just wanted to give you an update. I've been working on this for 2 days. The average guy with good eyesight could probably do this thing in an hour or less. It took me 2 days to do what you see here with these yellow caps. There were 10 of them that I put in here. But I don't mean 2 days like 8 hours a day. I might work an hour and a half. So I would say it took me about 3.5 hours to do this. Maybe 4 counting this here. So I would say, I would estimate in 2 days it took me 4 hours to do what you see here. As you can see, there's all 10 capacitors here. And the way I do them is I cut the leads very short to the body, hook, and if I can pinch it, fine. If I can't, I just hook and solder. So anyways, when I get all the resistors checked out, I will fire it up. What I did do though, since I changed all the capacitors, is I turned it on. I got no reception whatsoever, but the antenna is off. It's in the cabinet, in the other shed. But the audio amplifier is working. I get a hum when I touch the volume control, so everything in the audio circuit is working. I wouldn't expect the radio to work without the antenna on it, and I'm sure there were some bad resistors in here that have got to be changed out. Then of course I got to test the tubes. Now I know the rectifier is working, so I have to test all the tubes to make sure they're okay. And it's a mystery as to why they put 50 L6s instead of 35 L6s, which is what it calls for. I checked the tuning capacitor. There's no shorts. It's fine. I didn't have to disconnect anything. I put my meter on it. It showed infinity. So everything was good. So what I'm going to do after I check all the resistors and replace any that are needed, then I'm going to test the tubes. And then we may be ready to try it out. Okay, I stand corrected. This is a 50,000 ohm resistor. It's green body and dark. Green, black, and orange. $50,000. The schematic parts list, it's R4, showed that as a 50 megohm. I remember hearing somewhere that years ago they used M for 1,000. That never made any sense. So it's supposed to be a 50,000, not a 50 megohm. It's reading over 60,000. So that's going to get changed to a 47,000. That is located between pin 5, 2, 3, 4, 5, and 8. Or am I wrong? Yeah, 5 and 8. And there's another resistor on that pin number 8 also. Well, it's getting late here and I'm going to knock off for tonight. It seems like almost every dog bone resistor in this thing is off value. 3 meg here. I had to parallel to 6 megs or 6.3, I think, in parallel. These are half-watt resistors. What is originally in here, these here are 1/3 watt. So that's a 3 meg. This is 100,000. This read 167,000. So all of them are going up, and they're very, very, very difficult to change because the wires on these things are very thin. It makes it hard for me to work, and it's a Mickey Mouse job, I'll admit it. But best I can do.